Alright. So topik seterusnya adalah daripada chapter Harbor Heat from the Form 4 chapter. So let's see the question. Okay, so the first question here is there shows two different temperature of the pressure cooker. Okay, the first one is a low temperature and the second one is a high temperature, and the differences here is the outcome. Okay, the outcome here is the reading of the bottom gauge. Okay, the low temperature of the pressure cooker shows the lower reading of pressure, which is 138, and the second one shows the higher reading, okay, 184. So the first question they ask you about the what is the physical quantity that caused by the reading of the pressure gauge. So in here, what caused the reading of the pressure gauge? That is the fire. The fire means the temperature, correct? So the the physical quantity here is a temperature, okay, suhu. So class, kamu kena faham bezaan physical quantity dengan SI unit. So ada kalanya student buat kesilapan kat sini, dia pula pergi menyatakan Kelvin. Lagi-lagi salah mereka katakan Celsius pula, sebab dalam SI unit untuk suhu dia bukan Celsius, dia adalah Kelvin. Tapi walau bagaimanapun itu hanyalah untuk SI units, bukan untuk physical quantity. Okey, contohnya kalau soalan bagi kamu measuring cylinder, silinder penyukat. So if I ask you, what is a physical quantity measured by that tools? Apa jawapan kamu? Kalau kamu kata that one is a meter cube, sir, salah. Okay, so physical quantity for the measuring tools is a volume, isi padu. Benda itu digunakan untuk apa? Kamu kena bagi tahu. So untuk penyukat isi padu volume. Kalau kamu kata meter cube, itu adalah untuk SI units. Tetapi biasanya soalan akan tanya kamu physical quantity. Memang jarang dia akan tanya kamu SI units. Alright, so that is about the first question. Okay, second one. Why does the pressure increases when heated? Okay, mengapakah tekanannya bertambah apabila ianya dipanaskan? Alright, so untuk soalan ini, your answer should be based on the kinetic theory. Alright, so now you can see here there is a empty container. Okay, so as usual inside the empty container there is a gas molecule ataupun air molecule. Alright, so what this air molecule do? It will move fast and random. As what you know, you learn in your lower secondary, all the arrangement and the movement of the matter. Example, if a solid means the particles will vibrate at fixed position. If there is a liquid means it will move quite freely. If it comes to the gas, it will move fast and random. All right. So since the gas is moving fast and random, so they will collide among the other gas molecule. At the same time, they also will go and collide with the wall of the container. So the collision, this collision will create the pressure. So pelanggaran udara atau molekul gas ini dengan molekul lain dan juga dia berlanggar dengan dinding bekas itu. So pelanggaran dinding inilah yang menghasilkan tekanan. So setiap kali mereka langgar, mereka menghasilkan satu daya. So daya inilah yang kita mengatakan sebagai tekanan. So kalau daya ini, okay, ataupun kadar pelanggaran ini, the rate of collision is higher means we will say the pressure is higher. And also the vice versa, if the rate of collision is lower with the wall of the container, so we say that one is a low pressure. So we must know the sequence since the container is get heated until the pressure is increased. Okay, the first, once this gas or air molecule receive the heat energy, okay, once they receive the heat energy, that heat energy will make the molecule's kinetic energy to increase. Okay, the kinetic energy is increased, their velocity, or can say the speed of their movement will get increased. So it will cause the rate of collision between the molecule and the wall of the container will increase. Hence, this one will make the pressure to get increased. So I repeat again, okay. The first one, apabila gas molekulnya menerima tenaga haba first, tenaga haba ini ditukarkan kepada tenaga kinetik. ataupun ia menyebabkan tenaga kinetik gas molekul. Okey, ini bertambah. Disebabkan tenaga kinetik bertambah, ianya menyebabkan molekul-molekul ini bergerak dengan laju yang tinggi atau kelajuan yang tinggi. Lalu, kadar pelanggaran molekul ini sesama gas molekul dan dinding bekasnya bertambah. Dan finally, ianya menyebabkan tekanan dalam bekasnya bertambah. So this is how the explanation for the kinetic theory. So your answer should be based on heat energy will cause the kinetic energy to increase, and it cause the velocity or the speed of the movement, the gas molecule movement increase, and finally it will cause the rate of collision increase. And all this one will make the pressure get increase. All right. All right. So we're going to see one demo, or can say this is a simulator. Okay, the simulation, how this thing happen, how the pressure get increased based on the kinetic theory. Okay, the first one, we must know the manipulation variable. Okay, that is the temperature. So we're going to raise the temperature, we're going to increase the temperature and also the lower the temperature. Then we're going to see the output. The output here is the reading of the pressure. So at the default pressure is 1 atmosphere. We're going to see what happens when the temperature will get increased and also decrease. Okay, and then, so this one is a responding variable. Okay, and the third one is the volume. Okay, in here, we need to fix the volume. We need to lock the volume. So the volume should be in constant variable. All right. Okay, let's see, as in the normal room temperature, okay, or normal circumstance, what happened as we explained, as what we learned just now, all these gas molecule will move fast and random at the same time. They will collide the wall of the container. This is a normal stage. So this is what creates, or that is what caused the pressure to exist. Okay, then you can see the changes for the rate of collision once we increase or decrease the temperature. All right, let's see now. So this is a normal circumstance. So once we increase the temperature, we heat up the container, you can see the kinetic energy and the speed of the gas molecule, the movement increase, it caused the pressure to get increased. So once we lower the temperature, you can see the movement, the speed of the movement will slow down, and it causes the temperature, the pressure to drop. So again, we increase it, you can see the pressure get increased. So again, I'll tell you the first thing, once the container or the gas molecule receive or gain the heat energy, it will make the kinetic energy of the gas molecule to increase, and it causes the gas molecule to move in the higher velocity or moving fast, and the rate of collision between the molecule and the wall of the container will increase. All this one will make the pressure to increase. So faham clear dia punya ayat itu dengan dia punya sequence tu kena faham alright. Next. Okay, there's one daily life application equipment, okay, yang biasa kita guna, dan soalannya pun selalunya akan tanya pasal ini. So what is this? We call as a pressure cooker. Mesti semua orang pernah nampak, dan emaknya yang mesti pernah guna benda ni. And this one is always will make the sound will make irritate for me especially. Alright, sebab setiap kali yang steam, the high pressure of the steam dia release, it will create one whistle sound. That whistle sound will be in the high decibel. Quite high decibel. What? So it really will make irritate. Okay, but we see how it operates. All right. So since this one is a pressure cooker, so the function is to cook the food based on the pressure of the air. All right. So class, here for this pressure cooker, there has two safety features. The first one is a releasing valve, and also the second one is a safety valve. Okay, releasing valve, what happened? So this cooker is operate based on the pressure. So the pressure have their required, once the pressure exceed the required pressure. So what happened, what need to do, the excess pressure need to be released out. If no, it can cause explosion. Okay, the cooker can be explode. So what happened, that excess pressure will be released out from the releasing valve, because this one is made by a spring. So the excess pressure will push the valve and also it will be released out. Okay, so this is a normal operating system. This is how normally it function, it works. All right, but sometimes, okay, but it won't happen frequently, but sometime, or if the food or the pieces of the food is clogged, okay, is clogged, tersumbat, it's clogged in the pathway or in the vessel of this valve. So that time the excess pressure cannot be released out, and this one actually is very dangerous. As what I'm saying at the earlier, it can cause the explode also. All right, so during that time, so what will happen, you can see the second feature, which is we call as a safety valve. Okay, this safety valve inside here is a fit with the rubber. So when the excess pressure become an extremely high pressure, so that rubber will melt and it cause the safety valve to be kicked out. Okay, so benda ini akan tertolak keluar. So bila tertolak keluar, so what happen, all the extreme pressure can be released out. So once this thing, the safety valve is kicked out, so you have to replace back with the new rubber and fix back. But this one very seldom will happen. This one is only for the safety precaution. The second, the safety valve is only for the precaution step. Normally, the excess steam, okay, the excess pressure will be released by this valve, the releasing valve. So back to the question. So now I hope you all understand how this all the pressure and also the temperature is related based on the kinetic theory. So your explanation should based on that. All right, let's see. So the first thing you must know, when the temperature increase, it causes the kinetic energy of the molecule increase. So your answer must mention about the kinetic theory. So once the kinetic theory increase, it will make the speed of the gas molecule or the velocity of gas molecules to increase. And the most important, you have to state the rate of collision between the molecule and the wall is increased. And this make the pressure to get increase. Okay, so that is answer. Since this one mark, so as long you state the kinetic energy and also the rate of collision increase, you to get the mark. Okay, next, they will ask you to do a comparison. So as what we see from the picture just now, the first diagram, which is low temperature and the low reading of air pressure. The second one, high temperature, and also the reading of pressure also is higher. So everything you can use this symbol class. You can use the symbol of the greater and also lower. Boleh pakai. Tapi pada depan dia tolonglah menyatakan. Kalau soalan tanya, what they want you to compare? They want you to compare about the quantity of the heat. So you have to state quantity of heat from the first diagram. Sorry, the second diagram is more than the first diagram. The temperature of the second diagram is more than that. Same thing for the pressure also. Tolonglah bagi tahu apa yang kamu nak compare. Alright, next. Okay, based on the answer just now, what relationship between the temperature and also the gas pressure? So obviously kita dah tahu semakin tinggi suhunya, semakin tinggilah tekanan. Okay, when the temperature increase, the gas pressure increases. Jangan pakai berkadaran terus. If your answer is the gas pressure is directly proportional to the temperature, jawapannya salah. Kenapa salah? Okay, jawapan ini hanya boleh guna apabila grafnya, I mean the diagram yang dia bagi itu adalah graf. Sebab ayat direct or inverse, berkadaran terus, berkadaran songsang, kamu hanya boleh pakai bila adanya atau bilanya soalan itu merujuk pada graf. Kalau tak ada, tolong jangan pakai. Kalau pakai pun salah. All right. Okay, what physics law is this? So we must know, because as what we understand, this question is comes from the subtopic of the gas law from the chapter of the heat. So kita again we'll go to check briefly about all the gas laws. All right. Let's see. Okay, class. So this is the gas law. Okay, there's a 3 gas laws. Ada 3 hukum gas. Ketiga-tiga pun saya pakai formula yang sama. Kalau dalam buku you akan rasa tiga-tiga ni formula lain-lain. Okay, walaupun dia lain-lain, daripada it is all we call as a derived formula. Semua formula yang kamu kata lain-lain itu adalah formula yang diterbitkan. So apakah formula asal? The base formula adalah orang ini. So all the formula is derived from here. So saya akan tunjukkan cara untuk hafal. So before that, you must know what it stands for. All the variable here, PVT. Okay, of course it's in English. P for pressure, volume and temperature. Dalam BM tekanan, isi padu dan suhu. Okay, then I have a technique here. Kamu mungkin ada teknik yang lebih bagus. Kalau saya galakkan kamu kalau teknik bagus. Untuk saya hafal dengan cara ini. BT, CP and also GV. So what is that, sir? Okay, B stands for Boyle's law. Bukan Boyle's, Boyle's law. Spelling salah, nama orang spelling salah, jawapan boleh jadi salah. Alright. For the Boyle's law, you have to make the temperature constant. Kamu jadikanlah dia punya suhunya malarkan. So macam mana, sir? As what I'm said, for all the 3 are using the base formula. This formula. So what I'm going to do, I'm going to cut the temperature. Potong. Potong bukan maksudnya hilang. We make that variable as a constant. So once I cut, the balance, the remaining variable is become as a formula. PV. PV1 and PV2 apa benda, sir? Sebelum kejadian, selepas kejadian. Okay, that's what is the difference 1 and 2. Kalau kamu tak suka boleh letak AB pun. But the problem here, P and V also is a letter, is an alphabet. You nak letak A and B also is still a alphabet and letter. Mungkin confused. That's why we put a number here. Okay, second one, CP apa, sir? C for Charles law. For the Charles law, kamu potonglah P, pressure, tekanan. So the remaining is a formula. Third one, GV. G stands for Gay-Lussac law. Kamu potonglah V, volume. So the balance existing is this one. All right. So these are the 3 gas laws. Okay, ada gas, hukum gas. So based on the question just now, what are the 2 variables involved? So temperature and also the pressure. Yang mana kita dah buat constant kan? Volume kita buat constant kan? So yang mana? Nampak yang ni? So pressure and temperature and also the volume is constant. So yang tadi punya adalah Gay-Lussac law. One more thing, class. Okay, you can see out of the 3 formula, the Charles law and the Gay-Lussac law involve the calculation of temperature. Okay, in here, for most of the question, the temperature they'll give you in a Celsius. But for the calculation purpose, you have to convert into a Kelvin. Kena ke, sir? Mesti kena buat. Kalau tak buat, salah jawapannya. So how to do that, sir? From Celsius to Kelvin, you want to convert it plus 273. And also, your final answer should give back in temperature in Celsius balik. Kena bagi balik. Kena tukarkan balik. Okay, so how to do that? Your final answer from Kelvin change back minus 273. Okay, so what physics law is that? Gay-Lussac law. Again, I tell. Nama, spelling penting. Salah, jawapan boleh jadi salah. Alright, next. We see the calculation. Alright. So, suhu awal 6.1 is 109 degree Celsius. And suhu dalam period tekanan, jika tekanannya 180 is 10 ni 180. Okay, let's see. So class, the initial pressure 138 and the final pressure is 184. So what you do? So we're going to use Gay-Lussac law formula. So we're going to use this formula. So your first step is to list out all the info. So the initial pressure is what we seen just now, 138. And the initial temperature from the 6.1, soalan dah bagi dah 109. And as what I'm said, temperature mesti tukar pada Kelvin. How? plus 273. So you can see your temperature now is under a Kelvin. Then the final pressure 180. Okay. So the question wants us to calculate what is the temperature, the final temperature. So jika kita pakai Kelvin, jawapan akan dapat dalam Kelvin. Alright. So we're going to see that, the calculation. So we're going to do the cross multiplication. First, you substitute into the formula here. Then I think the rest all you know how to solve. Alright. So when I do a cross multiplication, I get the value of the x is 498.26. But as what I'm said, the answer is under the Kelvin. And we need to give the answer, the final answer in a Celsius. How to do that? Minus 273. That is the answer, class. All right. So that's so we will see you in the next question. Okay. See you. Bye.